It's homework time. Yes, happy homework time is here again. Lesson 21. Let's start off by jotting down our names at the top of the paper. You should put your name. You put my name, you're going to confuse somebody. And go ahead and write today's date. I will write today's date. You write the actual today's date. Number 1, division. Solve 35 divided by 2, okay, using an area model. Now that's easy, right? 35 divided by 2 is not difficult because what we're doing here, it's not about the answer. I can tell you the answer right now. It doesn't matter. The answer does not matter. It does not matter at all. What matters is understanding what you're doing when you divide. And then we'll use long division and the distributive property to record our work. But let's start off by drawing this area model. Okay, so now we know, and it really doesn't matter overly much what the rectangle looks like. It's just to give us an idea of what we're doing. So we know our divisor is 2. We'll put that for the length. And we know that this whole side, the entire inside of the rectangle, its area is 35. We're trying to find the width here. So when we look at 35, we want to partition it in a way that is useful to us. So we ask about how many tens of 2 in 35. In other words, skip counting by 2 times 10, 2 times 20, 2 times 30, and so on. So 2 times 10 is 20. And so 20 as far as we can go, because then it would be 40, right? So 20, that's where we come up with these numbers for this area model. So we say, okay, well look, I can do 20, and I know, I just said it, so I'm not going to pretend I don't know. I know that is 10, right? That 10 times 2 is 20. And then that leaves 15. But there's the rub. Before I go and write 15 here now, because we're a step on, last time we had no remainders, and it was like so easy, we whipped through that. Now we have remainders, because when I think about the 15 remaining here, and I skip count by 2's, I get to 14. See, so I'm going to have a remainder here. So I'm going to think of the 15 as 14 and then 1. So where do I put that 1? Well, here's how the Eureka folks want you to do it, is to just kind of append it on here and say, hey, look, here's that 1. Here's our remainder. Okay, so how many 2's in 14? 2, 4, 6, 8, 10, 12, 14. There are 7 with a remainder of 1. So we see how this works here? And so this makes sense. So 17 here, we'll make sure we understand what I'm talking about when I say 17. 17 times 2 is 34. And then I have this 1 over here, okay, which is my remainder. So let's do this same question out with long division and then the distributive property. So in long division, it would look like this. We'd say, okay, well, we're dividing 35 by 2. And we actually go through the same steps. But when we look at this 3, we'll think of it just as the digit 3 because we know it's in the tens place. Its value is 30. We don't have to say that. We know it. So how many 2's in 3? Well, there is 1. And notice that 1 in the tens place, that's our 10 right there. Because 1 times 2 is 2. And notice that 2 is in the tens place. Its value is 20. Here it is. There's that 20. So that 2, 20, 10 you see right here is right here. 2, 20, 10. Because the 2 and the 1, those digits are in the tens place. You see how it matches up here? Okay, so now I have handed out those 20 donuts, right, so to speak, those 2 packs of 10. And so that leaves 1 box of 10 donuts, which I'm now going to open up and combine with the 5 loose donuts I have so I can hand those out. That's why we bring down the 5. So your teacher might say, bring down the 5. We open up that box of donuts, we're taking those 5 loose donuts, put them together, say, okay, now we have 15 donuts left to hand out. And here are the 15, 14 and 1, right? So how many 2's in 15? Well, we already know there are 7 because 7 times 2 is 14. I'm subtracting that because I just handed out 14 donuts, 7 donuts to each of those 2 people. And that leaves 1 donut. And again, you see how this matches up. Look, 2, 14, 7, 1. 2, 14, 7, 1. It all matches up. Now with the distributive property, I'm going to write it underneath the area model here so you could see how it lines up. What I did was I said, well, let me do 20 divided by 2, right? And let me go straight down. So remember, okay, well that's 10, right? And then I combined that with, added it to, the quotient of, I really did 15 divided by 2, right? A couple of ways you could write this, right? You see that? Or I could write 14 divided by 2. All right, we'll do it that way. Because that's what I actually did in the area model, is 14 divided by 2. And we found that was 7, which was 17, right? And then we have this 1 here. So with a remainder of 1, which we need to put in our long division as well, that we had this remainder of 1. Okay, looky there. Isn't that sweet? All right, so number 1 is complete, and we understand what we're doing. Let's roll on over to number 2. And in number 2, we're doing pretty much the same thing. 79 divided by 3 we'll solve using an area model, and then again use long division and distributive property to record our work. Let's do it. So we need a rectangle for our area model. And now there's another little difference here in that when we talk about how many, as I put it, tens of 3s in 79, we're going to skip count by 30s, right? In the last one we skip counted by 20s, 20, 40, 60, and we only got to 20. But in this one, watch, 30, 60, 90. Okay, 90 is too much, but we can go to 60. 30, 60. So it's 2 tens of 3s, or 2 times 10 times 3, which of course is 60. So, and we know, because we just did it out on our little fingers here, that we're doing 10, 20 3s. We have 20. How many 3s in 60? There are 20. 3 times 20 is 60. Now that leaves, before we start writing anything, let's think, that leaves 19 out of that 79, right? 79 minus the 60 donuts here in the boxes of 10. That leaves 19, but we know right off looking at that 19 is not evenly divisible by 3. In fact, you probably know your facts well enough that you say, ah, yes, 3 times 6 is 18. So 3 times 6 is 18, and that 19 will be, that 19th will be that little remainder of 1 appended onto the side there. And so see how this makes sense? We're dividing by 3. Here's our 79, 60 and 18 and 1. 60 plus 18 plus 1, that's 79. There's our 79. Here's our quotient, 26, and we know we have this remainder of 1. That's why it's appended on there, like a little appendage. All right, so let's do the long division. You'll see how it matches up to the area model quite nicely. That's why we're doing it both ways, not just to make you suffer, although that is fun, but so you can see the connection here between the area model and the long division. So how many 3s in 7? Well, we know there are 2, correct? Because 2 times 3 is 6. So we've handed out those 7 boxes of 10 donuts, because it's a 7 in 10's place. We've handed out 6 boxes of 10 donuts, 60 donuts. There they are. And that's why we're subtracting them, because we handed those out. That leaves 1 box of 10 donuts, which we're going to open up. So we have now 10 loose donuts, which we combine with the 9 loose donuts to divide up those. That's why we bring down the 9, because we have all loose donuts now, the 10 that were in the box, and the 9 that were already running around loose. And now how many 3s in 19? So we can divide up these 19 donuts. There are 6 3s in 19, because 6 times 3 is 18. which leaves us with one donut that we cannot fairly share out. So when we write this out with the distributive property, what we did here was we said, hey, okay, let's do 60 divided by 3. And again, let's skip ahead and say, okay, we know that's 20. We just did it. And then we would combine that with, in both cases, the quotient of 18 divided by 3, which we know is 6. And so that gave us a quotient, just as we see here, of 26, and we do have this remainder of 1, which I like to notate here, and of course we need to put it in our long division as well, that we had that remainder of 1. There we go. There's our area model, long division, distributive property. Let's see what secrets and surprises number 3 holds in store for us. Yes. And I love questions like number 3 because we have Paulina, for one thing. She's cool. But more importantly, we have this area model that they're giving us and saying, okay, can you interpret it? Like, it's one thing to be able to make one, but can you look at someone else's work and interpret it? So what division did she solve here? She solved the following division problem by drawing an area model. What division problem did she solve? Whereas first, so we see that our divisor is 4. We're dividing by 4. And what are we dividing by 4? That's the tricky part here. 40, 40, 16, and 2. Okay, so 40 and 40 are 80. And 16, 80 and 16. Got that? 96 and 2. 98. So 98 is what we were dividing. That's our dividend. And we are dividing by 4. And that answers the question right there, but I always like to go a little bit further, make sure we understand what we're doing. Let's solve it. What is 40 divided by 4? Yes, 10. And again, 40 divided by 4 is 10. And then 16 divided by 4 is 4. Make sure this 0 looks like a 0. Whoa, now it looks like a mess. Okay. And then we know this is a remainder, right? That's why they're appended onto there. So 10 and 10 and 4, 10 plus 10 plus 4 is 24, and we have a remainder of 2. In fact, if we want to really earn our membership to Overachievers Anonymous, we can go ahead and check this answer to make sure we are correct by taking the 24, multiplying it by 4. 4 times 4 is 16. Place the 6, regroup the 1. 4 times 2 is 8, plus 1, cross it out, is 9. And then we have a remainder of 2, and I'm going to do that all together here. And of course we get 98, which is what we started with. So it checks out our solution there. Now, how can it be represented using the distributive property? So now she did it a little differently. I would have done 80 divided by 4 equals 20, but we'll use her model because, hey, that's what they're telling us to do. So 40 divided by 4 together with, again, 40 divided by 4 together with, added to, the quotient of 16 divided by 4. Okay, and that gave us 10 and 10 and 4. We already did this division up there, right? Which was, you got it, 24. And we did, I just want to notate here, that we had a remainder of 2 because we were solving 98 divided by 4. All right, hey, looking good there. So there's number 3, all set, wrapped up with a pretty bow. Let's open the next present in the next example. And now we get to do some practice. So we're going to kind of cruise through these. I'm not going to explain quite as much because I'm assuming you got the hang of the division area model here. So our instructions are to solve the following problems using the area model. We can do that. Support the area model with long division or the distributive property. I far prefer using long division because that's our goal here, is to learn long division. So we'll be doing that on all of these. So when we go ahead and draw our area model for 42 divided by 3, we just draw ourselves a simple rectangle. Our divisor is 3. How many tens of 3 and 40? Well, we skip count by 30s. 30, 60, 90, right? And we can only go to 30, right? So out of that 42, we can say 30 divided by 3 is 10. And from that 42, we've now handed out 30 donuts, 3 boxes of 10. And that leaves us with how many loose donuts? Well, 12, right? Well, actually a box of 10 that we're going to open up and make loose with the 2 loose donuts. And I can write that down with confidence because I know my multiplication facts. And I look at 12 and I realize there will be no remainder here. That's why I just went ahead and wrote it down. How many 3's in 12? There are 4. So they're starting off with a nice easy one here. And so that's done. What's our area model show the quotient to be? 14. 42 divided by 3 is 14. And that's what we will get, of course, when we go ahead and do our long division. 42 divided by 3. Well, how many 3's in 4? Skip count by 3's. 3. Yep, there's 1. And we subtract 1 times 3, which is 3. And we are left with 1 because we've handed out 3 boxes of 10 donuts, right? And we have that 1 box of 10 donuts left over. It's a 1 in the tens place. Notice still, don't forget, still got to line up all your place values in division. That law still holds. So I open up the box of 10 donuts, combine it with the 2 loose donuts I already have. There's the same 12 I had here. And how many 3s? Now I can divide them up. How many 3's in 12? Well, we already know, we just did it. There are 4 3's in 12. 3, 6, 9, 12. 4 times 3 indeed is 12, which is, as we found in the area model, leaving us with a remainder of 0, no remainder. Now we can see when we get to 43 divided by 3 that we are going to have a remainder. In fact, you can safely predict our remainder will be 1. Yes, because it's 1 more than 42. So they want to make sure we understand this. So let's draw our rectangle. And it's going to look very much the same. We know we still have a divisor of 3. We still know that there are 30. Right? We are how many tens of 3's, as I say, in 43? Well, we have 30 here because 30 divided by 3 is 10. And then that leaves us with not 12 this time, which we can just safely write down, but 13. Now we know that 13 is not evenly divisible by 3. And so we think, okay, well, 3, 6, 9, 12. That's as close as we can get to 13. So 12, and that was 3, 6, 9, 12, yes, 4. See, so right now it looks exactly the same as the previous area model, but here's the difference, which is we have that 13th left over here. That's our remainder. So now you see 30, 12, and 1. There's the 43 divided by 3 is 14 with this remainder of 1 appended on here. And when we check it again here with long division, we will find the same thing. 43, yes indeed, not 42, divided by 3. Well, how many 3's in 4? There's 1, because 1 times 3 is 3. We subtract, we handed out those donuts, that's why we subtract them. And we're left with 1 box of 10 donuts, a 1 in the tens place, which we open up and combine with the 3 loose donuts already rolling around the room. So how many 3's in 13? 3, 6, 9, 12. There are 4 3's in 13 because 4 times 3 is 12. And when we subtract, we have 1 donut left over. That is our remainder of 1. So you see here, 43, 30, 12, 1, 43, divided by 3 is 14 with a remainder of 1. See, it matches up perfectly. All right, let's do a little more practice now. More practice! There we go. All right, so let's dive right in here and not lose any time. Okay, so our area model for 52 divided by 4, we draw our rectangle, and we place our divisor of 4 over on the length. We're trying to solve for this width, right? And so we say how many tens of 4, is just how I put it, how many tens of 4 in 52? Well, skip count by 40s, 40, 80, 120, 160, right? So 40 is as far as we can get. So that's how we'll partition off the 52 as 40 And what remains of the 52 to be divided after we divvy up the 40? 12, right. Now, is 12 evenly divisible by 4? 4, 8, 12. Oh, it is. Look at that. So we can just go ahead and write the 12. There will be no remainder. We know already. And so how many 4s in 40? In other words, 40 divided by 4 is, or you could say 4 times what is 40? Yes, indeed, 10. And how many 4s in 12? 4, 8, 12. Yep, there's 3. And we already noted there's no remainder. So let's go ahead and do this out in long division. We got a quotient of 13 in our area model. Make sure we get the same thing here. All right, so how many 4s in 5? There is 1, because 1 times 4 is 4. Subtract, because we handed out those boxes of donuts. And there's 1 box of 10 donuts left over, which we're going to open up and combine with the 2 loose donuts already rolling around the room. So we have 12 donuts to divide up now for 4 people. They will get how many each? Yes, 3 donuts each, because 3 times 4 is 12. So we've handed out all those remaining 12 donuts with none left over, so no remainder. We got the same thing here. See, the 40 is right there. That's a 4 in the tens place. The 12 is right there. And the 13 is right there. Got it. All right, so now 54 divided by 4, we can see in a glance, because of its similarity to the last one, that we will have a remainder. In fact, you can fairly speculate that our remainder will be, right, 2, because it's 2 more than number 6 there. So let's see how that works. So let's draw our area model again. And it will start off similarly with our divisor 4. We already know that this will be 40. And we also know, you've probably picked up by now, I'm not going to write 14 here, because 54 minus 40, yes, is 14. But I'm not going to write 14 because that's not evenly divisible by 4. I'm going to work the division halfway. So 4, 8, 12 is what I'm going to write. And that leaves the 2, correct? So I'll append those on here. 1 and 1, right? Make 2. So how 40 divided by 4 is still 10, as it was in the last example. And 12 divided by 4 is still 3. So we again get the quotient of 13, but you see here is the remainder of 2, and that's of course exactly what we'll find when we go ahead and do this with long division when we say 54 divided by 4. And this is going to be nice and quick and easy because it's going to start off very similar to this one, right? How many 4s in 5? There's 1, because 1 times 4 is 4. Subtract, you get 1. And now we have 4 loose donuts to combine with the 10 in the box we opened up. So 14 donuts to divide up for 4 people. They will still receive 3 each because 3 times 4 is 12. But when we subtract now, unlike over here, this is the difference, we get 2 because we have a remainder of 2. And does it match up to our area model? Yes, quotient of 13. There's our remainder of 2, remainder of 2. Let's look now at 61 divided by 5, and I bet you can just glance at that and know we're going to have a remainder, right? Because anything evenly divisible by 5 is going to end with a 0 or 5. 5, 10, 15, 20, 25, 30. When you do multiples of 5 out, they all end up with 0 or 5. And so we know we'll have a remainder here. In fact, yeah, that's right. It will be a remainder of 1. It's good to kind of think logically about the example before you dive into it. All right, so we know our divisor is 5. How many tens of 5, as I like to say in 61? We'll skip count by 50s. 50, 100, 150, 200, right? So we know we can only get to 50. So let's call this 50, which is 5 times 10. And now that leaves, from 61, that leaves how much? 11. But we're not going to write 11 here because it's not evenly divisible by 5. 5, 10, okay, 10 is evenly divisible by 5, which will leave that 1. And so look, 50, 10, and 1, that's the 61. How many 5s and 10, by the way? 5 times what is 10? 5 times 2 is 10. So we see here we have a quotient of 12 with the remainder of 1. And now let's do the same thing in long division, which ultimately is our goal here, to learn the standard algorithm for long division. How many 5s in 6? Well, there is 1, because 1 times 5 is 5. We subtract, and we are left with 1 box of 10 donuts, which we open up and combine with the 1 loose donut already rolling around the room. So now we have 11 donuts to share with 5 people. Right? They will get 2 each, and that will hand out how many donuts? 2 times 5 is 10. Subtract, and that leaves 1 leftover donut, a remainder of 1. And does this match up with our area model? Yes. Quotient of 12, remainder of 1, remainder of 1. And now 73 divided by 3, you could probably also glance at and speculate that we will have a remainder. There are numbers that end with 3 that are evenly divisible by 3, but 73 just doesn't look like one of them, right? No, it really doesn't. All right, so let's try it out anyway. That's our speculation. All right, we'll draw our area model and say we're dividing by 3. Now, how many 10s of 3 in 70? 30, 60, 90. 90 is too much. So 30, 60 is what we have. Because 3 times 20 is 60. Now you could do this in 2 steps here. You could do, instead of 60, you could write 30 and 30, 10 and 10. It's the same thing though, right? So I'm cueing your head a little bit here. So we've handed out 60 donuts now from the 73. That leaves how many to hand out? 13. 3, 6, 9, 12. Okay, 13 is not evenly divisible by 3. The closest we can get, without going over, just like on The Price is Right, is 12. And that leaves 1 donut, right? Because 12 divided by 3 is 4. Okay, so look, there are 20 3s in 60. There are 4 3s in 12. And here's our 73. 60, 12, and 1 is 73. Our quotient is 20 and 4, 24. And we should get the same quotient when we divide out here in long division. So 73 divided by 3. How many 3s in 7? And now you see why I do the area model, by the way, the way I do, so that it matches the long division perfectly. How many 3s in 7? We know there are 2, right? And these are the same thing. A 2 in the tens place is 20, correct? So there's no difference here whatsoever. Because 2 times 3 is 6. And again, even though it says 60 here and we're writing 6, it's in the tens place. Its value is 60. It's the same thing. And that leaves 1 box of 10 donuts, which we're going to open up to make them loose donuts, combined with the 3 donuts we already had running wild. So how many 3s in 13? We're going to pass out those 13 donuts to 3 people. They will receive 4 each, because 4 times 3 is 12. And when we subtract, we are left with 1 donut left over. That's our remainder of 1. See, 24 quotient with the remainder of 1. Can you believe we just have 1 more to do? Let's do it. All right, and number 10, of course, we have to put our practice into practice by solving a word problem. Here we are. 97 lunch trays were placed equally in 4 stacks. How many lunch trays were in each stack? How many lunch trays will be left over? Okay, so look, we can just do simple little drawing here. I won't even call it a tape diagram, right? So we know we're going to have 4 stacks. And what we're trying to find, and there are lunch trays in these, right? This is a drawing, not an area model or a tape diagram. It's just a drawing, right? And we know how many lunch, because they're asking us how many, we know that we're going to have some left over, right? Okay. So what we're trying to find are how many are in each stack. That's an unknown. And we're also trying to find this, which I'll refer to as y. Okay, so let's draw an actual area model after we decide what it is we're doing here. See, the reason I drew this drawing here is to show that we are dividing. Okay, look, yeah, I know we're doing our unit on division, so you know we're dividing, but you see, this little drawing shows, oh, I'm taking those 97 lunch trays. That's all of these together. This is 97 trays, and I'm dividing them into 4 equal stacks with a remainder, okay? So you could see clearly then that we're dividing. Because when you go to take the big test or whatever, you won't necessarily know that you have to divide. It's not going to be like, hey, you have to divide here. You have to figure that out, and that's what the drawing tells us. So we're dividing 97 lunch trays into 4 stacks, and we know we'll have a remainder. So let's go ahead and now we can draw an area model because we know what we're actually doing. Now, how many tens of 4 in 97? Well, I'm going to skip count by 40s. 40, 80, 120, wait, hold on, 40, 80. That's as far as I can go. Because 4 times, that's right, 20 is 80, or 80 divided by 4, you could say, or 4 times what is 80. Now that leaves from the 97 lunch trays, that leaves me with 17. I can look at that number and know it's not evenly divisible by 4. 4, 8, 12, 16. Okay, that's as close as I can get to 17. And I could see 80 and 16 are 96, so I'm going to have 1 lunch tray left over here. That's my y. So how many 4s in 16? 4, 8, 12, 16. There are 4. So x, I can see how many in each stack is 24. So now to do this out in a long division world, we're saying 97 divided by 4. And this is going to look exactly the same as the area model. How many 4s in 9? 4, 8, 12. Oh, 12 is too much. 4, 8. So there are 2 4s in 9. Because 2 times 4 is 8. I subtract those 8. I almost said boxes of donuts, but we're talking about lunch trays here. Don't want to muddy the waters too much. So 9 minus 8 is 1. So the way to think about this, by the way, is that I took the lunch trays and I said, oh, okay, here's 20, 40, 60, 80. 20, 20, 20, 20. And see, so that's the 80 there. That's the 80. That's what that is. And now I still have 10 lunch trays and 7 lunch trays. Yes, yes, that I need to distribute out. And so with these 17 lunch trays, I say, well, how many can I put in each of these 4 stacks? In other words, 17 divided by 4. Well, I can put 4 more lunch trays evenly in each stack because 4 times 4 is 16. And that leaves me with 1 lunch tray that is kind of left over there, this leftover one. So a remainder of 1. And this is, by the way, you know, I always have students when we have questions about oranges or donuts or whatever, they're like, oh, well, you can cut up the donut. Well, that doesn't work in this one, does it? You're not going to cut up that lunch tray. Not unless you want to suffer the wrath of the lunch lady. And let's go ahead and earn our subscription to Overachievers Anonymous monthly by checking our division with multiplication. 24 times 4, well, 4 times 4 is 16. Regroup that 1. 4 times 2 is 8. Plus 1 is 9. That's 96, but we had a remainder of 1 to add in, that 1 leftover tray. And that is the 97 we started with. So it checks out too. Look at that. You are awesome. This homework time is complete. I will see you next time. It is once again homework time.